So anyways, like I said, 8 problems. The mixture will be the same or continuously, probably a daily one, a quarterly one, a monthly one, a semi-annual one. I try to get a little bit of a sampler platter of everything in here. So on this one, I kind of dropped the ball and I didn't do a monthly. I did 2 semi-annuals on accident. So just expect a nice mix back. So anyways, having said that, go through, figure out what formula to use. In problem one, you're using the parenthesis formula, the one with an N. And the work that I would expect to see on your paper is this. And any work that you have to do after this is really between you and the calculator. So if you feel like you want to show more, you're welcome to, but this is what I will look for when I grade your paper. So any questions as to how I got any of that? I don't, Haley, would you mind pulling the door shut? I'm about to lose it. Thank you so much. No, it's okay. I said sorry to them. Why you being this about me? You just made a face that was reminiscent of the Chick-fil-A girl with the Chick-fil-A sauce. Sorry. I'm recording. I need to stay on task. So, any questions about this at all? Now's your chance to ask, where does any of this come from? So to pass this quiz tomorrow, honestly, you just need to know, A, when do I multiply, and just type it in my calculator, and when do I divide? And since you're allowed to use a page of notes, it doesn't have to have a lot on it. But if it were me, guarantee you, I would make myself a page of notes and remind myself that when the variable I'm looking for is that one, this is a division problem. Maybe that's obvious to you, but it's critically important. Like, all your answers are going to be wacky if you don't know when to divide and when to just type it in. So what this winds up being, and I'm not going to go to this much length on every problem, but I just thought for the sake of the recording and any of you taking notes that I would write this down. So exactly into your calculator, you would put 1, 4, 3, 2, 2, 5, and then you would hit divided by. And then you would just start a set of parentheses and put in all the fancy stuff, the 1 plus 0.0729 divided by 365. And then you'd hit your little exponent button. And you don't need parentheses around this exponent because it's just a single number. Like sometimes if it's a multiplication problem or something, then you'd have to group it up. But in this case, you just hit to the power of, and that is that. And then you hit enter. And I would say, I know that we're not experts, but we're good enough at this to recognize when an answer is pretty stupid. And I feel like, if I get an answer like this one, it came out to $5,388.38. That, I have to know we agree is relatively reasonable. If I invest that much money and let it sit there for 45 years at a pretty good interest rate, it's going to make a lot. And that's kind of what this problem reflects. So I would watch out for answers that are obviously dumb and wrong. And you got to weed those out. So good. All right, so I'm going to go a little quicker now because like I said, I don't want this to take up our whole period. For question number 2, I'm just going to show the work step. Your work step should say A equals 255 times e to the power of, and I do like to put this in parentheses just so when I put it into my calculator, I don't forget. So 0.0803 times 70. And then this is not a divide because of what I'm looking for. So I just type that in literally as is. Listen, I really need to stress to you the importance of these parentheses there. I think most calculators, when you hit E, they're going to start the parentheses for you anyways. But if they don't, make sure you put them. It won't work if you don't. So you type that in and you should get $70,422 and some change, 18 cents. And remember, everybody, that dollar signs go on the left of numbers, penny signs go on the right. Okay, people mess that up all the time. So just a public service for you. Dollars go on the left, cents go on the right. Any questions so far? Good? You good? Okay, question number 3. did I already posted this on Canvas, right? Did I?
Yeah.
Okay, so you can go back and look at my work if you want to. But it should come out to $6,131.88. That's the final answer there. So good. Question number 4 is $436,191 and some change, 62 cents. Still good? I missed it once too because I didn't write the 225, so I feel you, brother. It must have just been a rough warm-up problem for us. So I'm glad I have whiteout because I had to use it yesterday. So the next problem is just a type it into your calculator problem. There is no division in a problem like this. So I just type it in as it is, and it winds up being $50,710.36 on the nose. Nice job. And what's up? Mhm. So again, I assume you'll stop me if you're not sure of how I got what I got, right? Okay, good. Number 6, semi-annual. That means you're going to put in n equals 2. And this is a division problem. When you type it all in and hit divided by, you should get $3,024. And again, a little bit of change, right? 14 cents. Still good? Dietrich, you good? Okay. On problem number 7, this, I know the answer seems kind of hilarious, but honestly, first off, 7.591% is a really good interest rate. It's not like the next one where it's 15%, but honestly, that's a good return. That's an insanely good return. And when you leave money for 80 years, I want to stress to you guys again how compounding works is that, there's a curve when you invest money. This isn't going to be like perfectly accurate, but the idea is when you invest money for the first 20 or 25 years, it hardly even perceptibly grows. It's like this. But what happens is every exponential curve has a point at which things start to go, and that's exaggerated a bit, but the trouble is, and we were talking about this earlier, is this right here, from here to here, like I'm not making this up. That's honestly like a span of 30 to 40 years. That's nothing exciting happens in the first 30 to 40 years because you're giving interest to something that's still pretty small. I don't know what the magic number is, but there's a point in every problem where something just like an eggshell just cracks. And then suddenly your compounding starts to do what it's supposed to do. So the thing with a problem like this is that you spend the first 30 to 40 years and not much happens, but then you spend the next 30 to 40 years this range here, and as you can see, this graph is headed nowhere but skyward, right? And that's where all the good stuff happens. So just a friendly reminder when all the annoying old people in your life tell you, "Oh, go invest while you're young, sonny." It's not just old person talk. It's mathematician speak for give your money a chance to do what you want it to do. If you invest when you're 40, it's still in its infancy when you're ready, long since ready to retire. Here you are 70, 72 years old, like, man, I'm ready. And your investment is still just doinking around. And that's because you never gave it a fair shot. So that's why in problem number 7, the answer is so obnoxious is because it has 80 years. And like I said, that's a good interest rate, 7.594%, so 7.591. So the answer that I got for number 7 was big, $9,694,023.27. So you think about, is that wrong? And then you look at the problem and say, I think it's okay. And again, the two factors again are the obnoxious amount of time and the very good interest rate. And a pretty good starting investment too, 25 grand. So that's a lot. Any questions on that one? The last one also I think is worthy of discussion just because it makes us feel like we did something wrong. The answer, by the way, is $66.43. And that's pretty unique because it's just not really what we're used to seeing. But again, I would ask you this before we turn the page. What about problem 8 makes it reasonable for 66,000 or $66.43 to eventually become, what is it? This would mean a lot to me if you can answer questions like this. I would know that I'm making a change with you here. How can that little tiny, that's like you and 4 or 5 friends, 3 or 4 friends go out to dinner. That's one dinner check, right? How can that turn into 500,000? What about this problem? Say it again. Yep. The 58 years is a lot, but it's not that. It's what Aiden said. It's what you said. It's the fact that that interest rate is insane. It's not really even realistic. It makes for a good math problem. But if there was anywhere out there where you could get 15.39% interest, wow, like sign me up for that, right? So don't want you to go out into the world expecting that you're going to go downtown and write a check and that you're going to get millions of dollars. Like it's not quite as simple as we math people would like to make it out to be. But that's why the answer is 66.43. Little bits can turn into big bits with really good interest rates. So that's that. Any questions on 1 through 8? Dalton, you okay, buddy? All right, good. These first few coupon problems I tried to make pretty straightforward. Then I tried to get, and I'm going to do the same thing when I go home and write the quiz tonight. I'm going to try to make sure you get a couple that are a little bit more challenging than the others. So, first one is a veritable snoozer. So, the item that I'm buying is $37.85. And again, my job is to figure out, I got a couple of coupons that I'm looking at. One of them is 40% off, and one of them is $15 off. Listen, you don't need a math degree to understand a $15 off coupon. Like that's just straight up. You literally subtract 15 and then you pay them that much. You do, however, need to know a little bit about math to do percentage coupons. So a 40% off coupon, what's the decimal for 40%? 0.4. Good job. So I'm going to take 40% like that, and you can put a 0 after it if you want to, either way. And I multiply that by the cost, which is 37.85. And that will calculate for me the amount that I'm going to save. And that in this problem came out to $15.14. In a case like this, honestly, you've heard the expression like 6 of one, half dozen the other. Like it's really not a big deal. 14 cents in the year 2024 is pretty minimal, but it's something. So I would obviously choose the 40% off coupon. And if you take some time to look at my answer key up on Canvas, you'll see I used like complete sentences and stuff. And someone asked yesterday, like, do I have to do that? And the answer is no. Just make sure there's enough work on your page that when I look at you picking a coupon that I can see that you're backing it up with sensible work. Okay. Next one, again, I think was just a warm up at this point. So we're buying an item on the next problem that costs $154.99. And one of the coupons again is just a no-brainer. It's just $40, man. Like you can't not you literally cannot not understand a coupon like that. You just take $40 off. The other coupon is a math person coupon, and that's 25% off. So we take 25%, which is 0.25, right? And we multiply it by the cost of the item, which is $154.99. You will calculate there that you're going to save $38.75. So this is the work I'm talking about. I can now justify my answer of saying I choose this coupon because I'm going to save more money this way. We agree? Okay. At no point in these problems am I asking you to calculate the final cost. So that's why we're not doing the percent off, percent on thing that we once discussed, in case you were wondering. At no point do I want to know how much an item's going to cost. I'm really just fixated on how much can I save? How much can I save? So that's why the approach is to just multiply and call it good.
Because there's no compounding.
There will be tomorrow. Oh, wait, I'll add it tomorrow. I'll make sure there's in fact, I'm going to put a sticky note on here right now. Say, make sure there's a con. Did I not put one on the whole? I did too. It's number 1.
I read it back.
Question 11, we are going to buy an item that costs this much, $317.25. And my coupons are, this time, neither one of them is a no-brainer. So I tried to now make it a little tougher. You can't just look at a coupon and go, bingo, I know what to do. Or like, I know how much it is. So they're both percentage coupons. The first coupon says I can take 35% off. But that 35% off only applies to anything above 200 bucks. So that's the store's way of saying we want you to buy more expensive items here, and then you can use this coupon because 35% is a pretty good deal, right? But they want you to get in and buy something bigger to be able to use that coupon. So the amount over 200 is $117.24. We good on that? Okay. So the 35% off only applies to this much of the price. The first $200 does not get discounted, but that 117.24 sure does. So into my calculator, I type 35% or 0.35, and I multiply it by 117.24. And I figured out with this coupon, I'm going to save $41.03. So I don't yet know if that's the best coupon, but I know if I go this route, I'll save that much off the price of that, whatever that is. Say like a pressure or power wash or whatever, something like that. And then the next coupon is 15% off, but this one's off the whole price. So this one I just take straight up the whole price. And so I'm going to multiply in my calculator 0.15 by the whole cost of the power washer. And I'm going to figure out that if I go this route, I can save $47.59. And I don't mean to insult your intelligence. It's never about that. I just want to make sure you understand that you would, in this case, choose this coupon because you save a decent amount, $6.56 more if you go that route. Good? 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 Boxer?
Yep.
Simon? Nunlenheimer? Good? All right, that leaves us with only one to go. So I'm going to buy 3 items, and they are $41.09. The next one is $17.87. Isn't that a significant date in history? Is that a thing? Okay, great. What am I thinking of? 17, maybe 76. That's a big one, right? That's like the signing of the Declaration of Independence kind of thing. Okay, but 1787. What's the thing with Columbus sailed the ocean blue? No, it has to rhyme with two because it's Columbus sailed the ocean blue. In 1492, Columbus sailed the ocean blue. Are you Googling that? Oh, okay. See if there's any historical. Okay. And then there's an item that costs $29.54. So the first coupon says, hey, go ahead and take 50% off, but it's only going to go off the least expensive item. So that 1787. Hold on, I got to pause this. Hold on, shut the front door. So I had it. There was a date there. So 1787, back in my dusty filing cabinet, 1787 was like the finalization, the signing. What was it? The what? So in September of 1787, the United States Constitution took effect. Hot dog. So this you can only take off your least expensive. So in this case, obviously the least expensive item is $17.87. So all I can do to apply my coupon is take 0.5, that's 50%, and apply it to $17.87. And when I do that, I'll figure out that if I walk up to the register and use my coupon, that coupon, I'll save $8.94. It's pretty good. If I go the other route with the 10% off, again, 10% to some people is like, well, that's why would you pick 10 over 50? Well, because this coupon applies to the whole thing, whereas the 50 only applied to one. So there's going to be that battle of like who's better. So in this case, the entire purchase means you have to add these three numbers together. And when you add all three of those numbers together, the total cost is 88.50. So then I'm going to take my 10% coupon, and if I apply it to that, that means I'm going to do like 0.1, and I'm going to multiply it by 88.5. That's my 10%. That's my total cost, and that gives me $8.85. Kind of like the first one, I feel like, is there a difference? Yes. Is it worth haggling over? Probably not. It's at the end of the day, it's literally 9 cents, but it is a math question on a test after all. So I would choose the 50% off coupon because I'm going to save 9 more cents that way. Is there anything else that you'd like to talk about or go over? I say I'll go home tonight and take a little break, and then I'll get to writing you a really good quiz for tomorrow. It'll be just like this: 8 questions on compound interest and then 4 questions on coupons. All right, well, I leave it to you. I'd love to work with you some more. I'll leave the recording paused, I guess, and then if there's anything that I feel like I'd have to add for Trinity or Micah or Aubrey, then I can add that in there. So